All right, so here's a question that a student asked, and I thought it was useful to just walk through it because this illustrates a lot of the good parts of the process of breaking down a problem, especially with projectile motion. So we have projectiles launched simultaneously from a cliff of height h. So we're going to make this height h here, okay, with the same initial speed. So same initial speed. It's always important to identify what what is the same here. So this is the same initial speed. One projectile is launched at an angle theta above the horizontal. Okay, so that's this one here. So it's going to go and land here. And then another one is launched at the same angle below the horizontal. Again, theta. Again, V0. And this one, I'll use I don't know, green for the path. And say it would be like this. And we would like to know the distance between the projectiles when they hit the ground, right? So picture's super, super important. And let's do the black one first. The black motion first, where we're doing this projectile one here. And always what I explain to students is you want to list out all of the quantities. I never just jump straight into equations because it's just with a complicated problem, you just want to think about setting up the variables and setting some direction. So let's say we'll make right as we also need to assign direction. So say right is positive and up is positive, okay? You don't have to, but let's say I choose to do it that way. Okay, so displacement. I do want the horizontal displacement. The displacement is actually technically this vector right here. This is my displacement vector from where I start to finish. But it's really split into two components. There's a downward component and then a rightward component, right? That's called the vector decomposition. So it actually falls a distance h and goes to the right some distance. Now, I would like to know this distance because I want to know how far apart these guys are. So I'm very interested to know what this value is. The vertical displacement is downward h. See, the arrow is pointing down, and I said down was the negative direction because I said up was positive when I established this. So this is negative h. Okay, now we do the same thing with the initial velocity. We have to do this decomposition part. Okay, so now I have to decompose the initial velocity, and I don't know the initial velocities. I just know that they're kind of the same. This is v0 cosine theta is the horizontal one pointing to the right, and then this one's pointing up. That is v0 sine theta, and it's positive because it's pointing up. Awesome. Final velocity, not stated in the problem. The acceleration we assume to be downward at g. Okay, downward. So it's 0. There's no horizontal component, but there's a vertical component downward at 9.8 meters per second squared. Down is the negative direction, so I will put negative g here. Okay, and how do I usually connect these things is the time is connected between these two. So the way you want to think about it is the displacement. What equation is going to connect these quantities is this equation. For the x direction, what does that equation become? It becomes the displacement is v0 cosine theta times t. Okay. And yeah, and then there's no, because the a is 0, that zeroes out. In the y direction, what does the equation become? Well, the delta x is negative h. That's v0 sine theta times t minus 1/2 gt squared, because the a I replace with negative g. Okay, so that's my equations here. Now, standard method is if I want to find this quantity, I need to know the time here, right? And then I'm going to plug that into this into this thing. So this is quadratic in t. So the tricky thing about this one, we've got to use quadratic formula to solve for the t directly. So we're going to move this to this side, 1/2 gt squared, and then move that over here. Oops, not equals. Minus v0 sine theta t minus h is equal to 0. Okay, and then I'm going to multiply. What am I going to do? Well, we'll just leave it like that. We'll just do, so the t is going to be negative b. This is my b, so it's going to be positive v0 sine theta, plus or minus square root of b squared, this quantity squared, which is v0 squared sine squared theta, minus 4 times a times, 4 times a times c, that's 1/2 g times negative h. Okay, divided by 2 times a, which is 2 times 1/2 times g. Okay, so this is going to be v0 sine theta plus or minus this quantity here, which would just leave it like that. And then just make that plus 2gh, okay, over g. Now, which time makes sense? The one that makes positive answer. If I use the minus one, it's going to give me a negative answer for time because this quantity is bigger than this quantity. So basically, the time is just going to be the one where I add them. And then that goes into the displacement, where was it? The x displacement to get the horizontal displacement. So then the horizontal displacement is v0 cosine theta times this quantity here, v0 sine theta plus, oh, it's going to be a lot of space, so let me erase this, times this thing here, square root v0 squared sine squared theta plus 2gh all over g. Okay, so you get this quantity here. Okay, so that was a lot of work. We just did one. But that would give us an answer. That would be an expression that gives us the distance from there to there. Now we got to talk about the green one. What's different about the green one? And let's just be a little bit more critical here. What's critical in terms of what's the difference in here? Well, the horizontal displacement is clearly different. It still falls the distance h, so that part still is the same. The v0, if I break down it, what's going to happen, though, is the v0 cosine theta is the same, but the v0 sine theta is going to be pointing downward. So in the second scenario with the green object, it's going to be minus v0 sine theta. Acceleration's still the same, and it's be the same process. So basically, we're going to get the same answer as this, but we replace v0 sine theta with negative v0 sine theta. And that's because it's pointing downward instead of pointing upward. That's really the only key difference between the two. So then the other one, the second, the one that's aimed downward, is v0 cosine theta times negative v0 sine theta plus the square root. Now when I squared this quantity, because this was like negative, but then I squared it, it still stays positive. So that part doesn't change actually. Because when you square a negative number, it's still the same number. It's just positive, right? So then we have this, okay? And ultimately what we want to do is we want to calculate the difference between them, right? So they're mostly going to be the same. Now, the easiest way to think about it is this v0 cosine theta is, let's distribute this. So that's going to be v0 squared cosine theta sine theta over g. And then it's going to be plus this v0 cosine theta times this guy. So that's the delta x1. All I did was distribute the v0 cosine theta and split them apart. And then do the same thing here. This is going to be minus v0 squared sine theta cosine theta. Oops, I did this cosine theta. Cosine theta sine theta. It doesn't really matter. And then plus this v0 cosine theta root v0 squared sine squared theta plus 2gh all over g. Now what's cool, and why the answer is simplified out, is because this quantity and this quantity, they subtract out. So they're going to negate each other. And this minus make it positive, so then you have this plus this. You have two of those. So you have 2 v0 squared cosine theta sine theta over g. Okay? So this illustrates process. Now the math was a little bit intense, but the process is the most important thing that you guys want to be focusing on here. So it's going to be this guy right here. 2v0 squared cosine. Oh, there's a sine. There should be a sine theta. Ah, okay. So this is a little bit tricky. This is probably a little bit advanced. Okay, so this one doesn't match because it doesn't have the sine. It's cosine squared, cosine squared, cosine squared. It's actually this guy. And this one's kind of annoying because you have to know this identity. 2 cosine. Well, actually, I think all of these are wrong. Because I think it's supposed to be, it's not going to be cosine squared. Yeah, actually, I think all of these are the wrong answer. This is the answer I would have gotten it. You can simplify this if you want. 2 cosine theta sine theta is sine of 2 theta. So you can write this as 2v0 squared sine of 2 theta over g. That's another way to do it, but none of those have those as an answer. So I don't know. I don't know what to tell you. It shouldn't. There should not be a cosine squared for any of these. So I think all of these are actually wrong. So that was a poor part of the problem. I'm pretty sure I did this right, unless I did some algebra, made a mistake in the algebra somewhere. That is what I would say is the correct answer.